Okay, so continuing with letter C, we just canceled sine and reduced this to be just sine, and we know that's over, because that's over 1. So we're left with secant theta times sine theta. Any ideas now? We're not down to one trig function yet. What can we rewrite either one of these? Secant. What can secant be rewritten as? 1 over cosine times sine over 1. So we get sine theta over cosine theta. What do we know sine over cosine always equals? Sine over cosine equals tangent theta, and that's my final answer. So let's move on to the last example. Sine theta times cosecant theta minus sine theta. What's the only thing up there that can be rewritten? Cosecant. Because there's no sine square, so there's no Pythagorean relationships going on. If you notice, all the Pythagorean identities have squares. So yeah, that's right, cosecant. What can cosecant be rewritten as? 1 over sine minus sine. Then, any ideas how you would simplify this? What do you think you might do next? Okay, any of you thought distribute? You're right, we're going to distribute sine. What is sine times 1 over sine going to make? The sines are going to cancel and I'm going to be left with 1. Then we distribute here. We get minus with sine times sine. Sine times sine is sine squared. Where have I seen that before? Any of you thought, ooh, that's a Pythagorean identity? You are correct. What's the Pythagorean identity that involves sine squared? It is cosine squared plus sine squared equals 1. What have they done with the sine squared? They've moved it to the other side. So 1 minus sine squared equals cosine squared. So what do we know 1 minus sine squared equals? It equals cosine squared. So we're left with a single trig identity. Good. Now some of you may say, Ms. Kramer, back on letter B or a different problem. I did it a little bit different, but I ended up at the same answer. That is going to happen. I might choose a different way to get there. Some of you might do it a little bit differently and end up the same. That's fine. There's no one way to do these. That's what actually makes this a little more difficult, because there's not one way to approach a problem, but we should all end up at the same final answer. As long as you only rewrite these using different identities that we've learned today, you should ultimately get back to one of these final answers. It is very important on quizzes and tests that you show all work. I don't know what's going on in your brain. So if you go from here to here, I might not give you full credit because I don't know how you made that jump. I need to see this in between step. So make sure you're showing all work on these identities. And that is it for today.